Hello students. So as you know, we have completed the chapter, the seventh chapter, alternating current. Okay. So without wasting much time, we'll solve some problems on the alternating current chapter, and with this we'll sum up with the chapter. Okay. So as I told you, it's very essential to list the formulas which are coming in the chapter after finishing every chapter and when you are going to solve the problems. Okay, so before solving the problems, keep a practice of listing the formulas in that respective chapter. Okay, so I hope all of you are ready with your list of the formulas, and I have made the list of the formulas coming in the chapter alternating current. Okay, so I have started with the alternating current formula, which is I is equal to I naught sine omega t, and alternating voltage is V is equal to V naught sine omega t, where this I and V are what? This I and V are instantaneous currents, okay, and instantaneous voltage, and I naught and V naught are peak values. Okay, omega is angular frequency, T is time. Next comes is mean or average value, that is of alternating current, that is I average. IAV is equal to 2 by pi I naught, where I naught is the peak value of current. RMS value, and inductive reactance, capacitive reactance, impedance. Okay, I'll send this list to you, don't worry about that. And next we have the resonant frequency, which is the frequency of VLC oscillations, you can say. V naught mu naught is equal to 1 by 2 pi square root of L into C. Q factor formula is there. In this, what are the terms? L is nothing but inductance of that inductor, C is capacitance of the capacitor, R is resistance, 2 pi, mu naught is the resonant frequency, and we have the power in AC circuit. P is equal to Vrms into Irms into cos pi. These are the RMS values of voltage and currents, as you know, and cos pi is a power factor. And at the last we have the concept of transformers, and in that we have some formulas like this ratio we have. When you consider the turns, ES by EP is equal, or NS by NP is equal to K. K is called as the turns ratio or transformation ratio, and efficiency of the transformer. Means ideal transfer is having 100% efficiency, like that. So efficiency is also having the formula. Okay, I'll send this formula to you. Okay, so our main work today is to solve the problems. Okay, so by considering that formula list and the concepts of the chapter, I have collected some important problems for you. Okay, so let's solve one by one. Okay, so first one. Okay, I have written the questions first. Okay, so see here, the first question is, the equation of an alternating current is I is equal to 20 sine 300 pi t. Calculate the frequency and RMS value of the current. So this is the question. Okay, so how to solve this? And as I told you, to solve the problems we have to follow 5 steps. I hope you can remember that. What are those 5 steps? Try to remember. The first one. Okay, I'll keep this list aside. The first step to solve the problems is what? Yes, it is to write about the given things. What are given things in that question? You have to write. Next, what they have asked means what we have to find, that you have to write. Next, formula used in that problem. Next, substituting the values and doing the calculations. And next, last step is result should be with unit. Okay, so in the last chapter only I had told these steps in detail. Okay, so by solving by using these 5 points we are solving the problems of today. Okay, so the first question I had told it to you already. Okay, so in that so see, once again I'll read the question for you. The equation of an alternating current is I is equal to 220 sine 300 pi t. Okay, calculate the frequency and RMS value. So this problem is much easier. So what they have given? They have given this equation and they are told to find the frequency and the RMS value. Okay, so what they have given, first point given is what? They have given I is equal to 20 sine 300 pi t. Okay, next what they are told to find? What they are told to find? They have told calculate the frequency and RMS value of current. Means frequency and RMS value of current means I RMS is equal to what? This you have to write. Okay, so third thing, what are the formulas you are going to use now? What are the formulas we are going to use? Okay, so you already know I is equal to I naught sine omega t. So here in the given we can also write I is equal to I naught. I naught means the value of I naught, peak voltage is 20 ampere. This is also given. Sine omega t we'll write na. So in the place of omega what we have? 300 pi. Okay, so this much things they have given and this much things we have to find. Okay, now to find mu, what is the formula we have? How to find mu? You know, omega is equal to 2 pi mu. So mu is equal to 2 pi by omega. But you don't know the value of omega here because they have not mentioned omega only. But by looking at this, I is equal to I naught sine 300 pi t. So you can write omega is nothing but what? 300 pi. Isn't it? Omega is 300 pi. So okay, omega is 300 pi. So now substitute. Here omega is equal to 2 pi mu. So mu is equal to what? Omega divided by 2 pi. Okay, and what is the value of omega we have? 300 pi. 300 pi divided by 2 pi. 2 ones are 150. So mu, the value of frequency mu is what now? 150. Okay, and 150 what? Unit we have to write na, mu 150 hertz. Okay, so now we got the equation, we got the value for frequency now. Okay, also they have asked one more thing, what is the RMS value of current? Also they have asked na? So that also we have to find. So as you know, we have the formula. I have mixed the formula and calculation part na? Okay, so this is the formula number 1. Formula number 2 is what? I RMS is equal to I naught divided by root 2. So now this is the fourth part. This is calculation. So in that only I am doing the calculation. So I RMS is equal to I naught. What is the value of I naught? I naught is given 20 ampere. 20 divided by root 2. And that is something around 20 divided by root 2 means 1.4, 14.14 ampere. Okay, so this is the calculation part. This problem is easier one, that's why I'm telling it fast. Okay, so last part is what? Result. How to write the result? Mu is equal to 150 and IRMS is equal to 14.14. Okay, is this enough? No, result should be with unit. Okay, so 150 hertz and IRMS ampere. So this is the first problem. Okay, next we have done with it. Next, see, the peak voltage of AC supply is 600 volt. What is its RMS voltage? Means they have given the peak voltage and they have told to find the RMS voltage. This is the question number A. In that only same, the RMS value of current in an AC circuit is 20 ampere. What is the peak current? Means the intention of this problem is what? The relation between RMS value and peak value. Okay, so A and B. So what is A? Peak voltage is 600. What is RMS? Second problem, peak voltage they have given V0 is equal to 600 voltage. So now how to find the RMS? VRMS is equal to V0 divided by root 2. I'm solving it fastly and without all these steps, okay, because we have still 4 to 5 problems to solve, but you know what is the exact step to solve the problem. Okay, this is a simple one. Okay, but you have to follow the process. 600 divided by root 2 means 424.3 volt. You have to write volt is the answer. Okay, this is A. What is B? The RMS value of current in an AC circuit is 20 ampere. What is its peak current? Okay, means RMS current they have given 10 ampere. They have told to find what? I0. So what is the formula? IRMS is equal to I0 divided by root 2. So what is I0 is equal to IRMS into root 2. Okay, so what is the value of I0 now? IRMS value they have given 10 into root 2. 10 only, na? RMS value is I0. Sorry, it is 20. Anything it may be. Just the intention is to get clear with the formulas. So it is around 28.28 ampere. Understood? This is the simple one. Okay, next. Okay. See, third problem. When a given coil is connected to a 200 volt DC source, 2 ampere current flows, and when the same coil is connected to 220 volt and 50 hertz AC source, only 1 ampere current flows in the circuit. Means what is the exact situation? We are considering one coil. We are having one coil we are having. Okay, this coil we are connecting to 200 volt DC source. 200 volt DC source. So at that time 2 ampere current flows in the circuit. Okay, so this same circuit, we are connecting it to what? AC source of 220 volt and 50 hertz. 220 volt and 50 volts. So at that time 1 ampere current flows. Okay, this is the situation. Okay, so they have asked in the question why the current decreases in the latter case. Why the current decreases? That is the question. And next is calculate the self inductance of the coil. Okay, so now let's go to the problem in detail. What is the situation? One coil, initially it is connected to a DC source, okay, of capacity 200 voltage, okay. At that time 2 ampere current is flowing. The same circuit is connected to AC source of the capacity 220 volt and 50 hertz. But here we have increased the voltage, but the current decreases. This is the situation. So in the first question they have asked why the current decreases, and in the second question they have asked calculate the self inductance L. Understood? So now what is the given things in this problem? What are the things they have given? In the first source, in the which source? DC source. What is the voltage? 200 voltage, and in the current is 2 ampere, and in the AC source voltage is 220 and frequency is 50 hertz and the current is 1 ampere. This much only, na? Okay. So next they have told to find L. They have told to find L, self inductance. Okay. So first question they have asked why the current decreases. They have asked why the current decreases in the case. Okay. So when the coil is connected to AC source, it's when it is connected to DC source, it is having the 2 ampere current. But when the same thing it is connected to AC source, what happens? It's reactance, inductive reactance XL is there, inductive reactance, it increases because it is connected to a AC source. The inductive reactance XL increases. Okay, so because of that the current in the coil decreases. Inductive reactance is nothing but what? The opposition offered by the inductor to the current. Yes, so if the opposition increases, the current obviously decreases. So this is the answer for the first question. So next question, to find the L. So to find the L we have to get the formula. Okay, we have the formula for XL but we don't know L. So what you have to do, you know V is equal to IR, you know it already. So I is equal to V by R. But when it comes to the case of inductance, the R is what? L only, na? It means opposition is what? XL only, na? So I is equal to V divided by XL. I is equal to V by R is in general. So in the time of inductance, the opposition is nothing but inductive reactance only. That's why I is equal to V by XL. So and what is XL? You know, L omega. So now what? I is equal to V divided by L omega. So what is L is equal to now? L is equal to V divided by I omega, and V divided by I omega is nothing but 2 pi mu. Okay, now substitute the values. So for the DC source, you know what is the AC source, what is the voltage? You know, 220. Why I am using the AC source voltage only? Because the XL is there in AC source only, na? Understood? Okay. So what is the value of current in AC source? 1 ampere. 3.142 into mu is 50 hertz. So it is 220 314. So it is 0.7. Inductance is 0.7. Okay, so we got the answer. Inductance is 0.7. Okay, last thing means this is formula and calculation. I'm mixing up everything. Okay, don't do that. Result. Inductance is 0.7. Next, what is here? Unit of the inductance is Henry. H. Unit of inductance is Henry. Okay, so this is the third problem. Okay, I'm sorry if I'm going fast, but you can you watch in the video properly, because it is not live. Okay, it is recorded, so you can watch it by skipping further or skipping backward. Okay, you can watch it, no problem in that. Okay, next. Okay, understood na all the three problems? Okay, fourth, a 40 ohm resistor, a 3 millihenry inductor and 2 microfarad capacitor are connected in series to a 110 voltage 5000 Hz AC source. Calculate the value of the current in the circuit. Okay, understood the question? What they have given here? Let's analyze the question first. A 40 ohm resistor, 3 mH means millihenry inductor and 2 microfarad capacitor are connected in series. Okay, so let it analyze it first. Fourth number. Okay, a resistor, a inductor, a capacitor. What is the values? 40 ohm, 3 millihenry and 2 microfarad. A capacitor connected in series to a AC source of voltage 110 voltage and 5000 Hertz. Okay, this is what they have asked. Now calculate the value of current in the circuit. Okay, so this is the analyzation of the problem. First, what are the things they have given? R resistor 40 ohm, L inductance 3 millihenry. Milli is nothing but 10 raised to minus 3. So I'll write it as 3 into 10 raised to minus 3 Henry. C capacitor 2 microfarad. Micro means what? 10 raised to minus 6 farad. And the voltage of the AC source 110 voltage and the frequency of the AC source 5000 Hertz. These all things they have given. Okay, these all things they have given. This is correct. Now what they have told to find? They have told to find the calculate the value of current in this circuit. Means value of current in this circuit is nothing but what? Impedance. Current. Calculate the current they have asked. Means they have told IRMS. They have told to find the IRMS. Okay, so what is the formula we are going to use here for IRMS? It is V by R. V means what? When you consider the RMS current, it is RMS voltage, and the R is nothing but Z. Okay, so now you have understood. You may have understood how to solve this problem. Okay, so first we have to find the Z value. And VRMS we already have, so that we can find the IRMS. Okay, now let's calculate Z. How to calculate Z? Z is nothing but what? Z is equal to square root of R square plus XL minus XC square. You already know R. XL, L you know, XC, C you know. Okay, so now let's start. Okay, so now first your first work is what? Means you have the formula Z is equal to square root of R square plus XL minus XC square. So let find the R square first. R square is nothing but what? 40 ohm. 40 into 40, 1600 ohm. Okay, next let's find the XL. XL means what? L into omega, but we don't know omega. What is omega? We don't know. But so omega is what? 2 pi mu. Okay, so now in that you know L, you know mu. L is nothing but what? 3 microhenry, 3 millihenry, and mu is 5000 hertz. Okay, so XL is equal to what? L 3 into 10 raised to minus 3 Henry into 2 into 3.142 pi value and 5000. So it is around 94.2. What is unit? XL and XC are nothing but what? Oppositions. So hence it is. I have solved the problems already and I have calculated them. Means while recording the video it will consume much time. That's why I have calculated all the things first only. That's why I am solving. Okay. XC 1 by C omega. C is already you know. Value of C already you know, 2 into 10 raised to minus 6, and at the place of omega 2 pi mu. So now 1 divided by C, 2 into 10 raised to minus 6 to 3.142, and mu is 5000. So XC is equal to 15.90. You just can check the values once again. Because to reduce time I have calculated all the things initially. So now Z is equal to R square. R square is what? R square is what? 1600. So 1600 plus XL minus XC whole square. What is XL? 94.2 minus XC 15.92 whole square. Now you calculate it in detail. I'll write the answer directly. 251.4 pi omega. Z is also a position impedance. Okay, now what is our main intention? We are supposed to find the IRMS. You know already the value of VRMS. What is that? 110 volt. So 110 divided by 251.45. So IRMS is equal to 0.44 ampere. Okay, now write the result. Result is IRMS. The current in the circuit is 0.44 ampere. Okay, understood? So if it is fast, okay, you can watch the video as per your convenience. Don't worry about that. But I am focusing on solving much problems. Okay, so we have solved 4 problems. Okay, you can also have the questions from the various textbooks or various source, or you can ask to me and try to solve much problems. Okay, next, a series LCR circuit with L is equal to 5.0 Henry, C is equal to 80 microfarad, and R is equal to 40 ohm is connected to a variable frequency source of 230 volt. The same situation in the last problem how we had done na? One inductor is there, one capacitor is there, one resistor is there. They are connected to a frequency, a source of frequency. Frequency is variable and the voltage is 230 volt. Okay, so in that problem they have asked determine the resonance frequency of the circuit. Resonance frequency, try to remember what is that. Mu naught. Obtain the impedance of the circuit and amplitude of the circuit at resonance. They have told to find three things. What? Given all the things you know. Fifth problem. Given they have given L is equal to given 5.0 hertz, C is equal to 80 microfarad, and R is equal to 40 ohm, and VRMS is equal to 230 volt. Okay, and what they have told you to find? What they have told you to find? Resonance frequency of the circuit. And they have asked to find the resonant frequency. Mu naught is equal to what? And impedance. Yes, impedance. Z is equal to what? And amplitude is equal to what? Okay, so now what is the formula we are going to use here for the mu naught? Resonant frequency means in the concept of electrical resonance you have got the resonance frequency. Okay, so that is 1 by 2 pi square root of L into C, and Z is you already know, R square plus XL minus XC whole square, and amplitude I will tell it later on. Okay, so mu naught, first calculate this. Fourth thing, mu naught is equal to 1 divided by 2 into 3.142 into square root of L into C. L is nothing but what? 5 Henry. C is 80 microfarad. 80 10 raised to minus 6. Okay, so it is around mu naught is equal to 7.96 hertz. Okay, that I have calculate this, you will get the answer this much. Okay, so now next thing is Z is equal to what? Okay, so to calculate Z you need XL and X omega, but to find XL and X omega you need omega, but to find omega you need mu. Yes or no? So but in that expression what they have told, in the question what they have told, variable frequency source means frequency is varying, and the condition is what? Which condition we are having there? We are having the resonance condition. Understood? That's why the impedance of the circuit at resonance is given by Z is equal to R. Okay, and that is nothing but what? 40 ohm. Yes, so this is impedance. Now what is amplitude of the current? Amplitude of the current means I naught, amplitude of the current, that is nothing but V naught divided by Z. Okay, this is the amplitude of the current. Okay, so now result, mu naught is equal to 7.96 hertz, Z is equal to 40 ohm, and I naught is equal to V naught Z. That amplitude is theoretically explained. For that we don't need any calculation. Okay, so don't much bother about that. Okay, so the last question. A step-up transformer operates on a 230 volt line and a load current of 2 ampere. The ratio of the primary and secondary windings is 1.25. 1:25. 1:25 ratio. 1:25. Like this ratio is there. What is the current in the primary cell? Okay. So they have asked about a step-up transformer arrangement. Okay, in that they have a 230 voltage. 230 volt, it operates on 230 voltage. Okay, and the load current of 2 ampere. Load current means what? You know the transformer. You know the transformer. How it will be? Sixth one. It will be like this. The iron core and the transformer, primary shell and secondary shell. So here we are having the input, primary, and here we are having the load, output. Okay, so this is for primary cell, this is for secondary cell, and where the current we are having is IP, we are having here is IS, and the windings we are having here is NS, and here it is NP. So they have to given, what they have given here, see, the load current of 2 ampere means they have given IP already. IP is already 2 ampere. They have given it. And what they have given again, primary and second, the ratio of primary and secondary windings is 1:25. 1:25 is what? The ratio of windings. Winding means what? Number of turns, NS and NP. So it is NP and NS. Understood? So what all the things they have given? IP is equal to 2A. Okay. NP is equal to 1 and NS is equal to 25. And what they have asked? What is the current in the primary cell? So primary means IP. What is IP? They have asked. Okay, you have a very simple formula over there. The ratio you have, na? The ratio we have, what is that? NP divided by NS is equal to IS divided by IP, or also we are having ES divided by EP. Okay, so now what is IP now? IP is equal to, send it to this side, send all these things to this side. IS divided by NP. NP comes here, NS goes here, NS. Okay, so you know all the values. IS is 2 ampere, NS is 25 divided by NP is 1. So what is the value of IP? 2 into 25. IP is equal to 50 ampere. Understood? This is the answer. I have not followed the steps completely. You may understood this. Okay, so these are the some important problems. Okay, I'll send this problem questions sheet also and the formula list also. Okay, go through it properly and try to solve much problems from the other sources, or if you want some more problems, ask me. Okay, so I think for this much is enough, I think. Okay, so if you want, you can ask me. We'll solve some more problems in one more class. Okay, so if you want, tell me. I'll make one more video on the other problems also. Okay, text me or call me or inform me anyhow if you want some more problems. Okay, but if I don't get any requests to solve the much problems, I'll directly jump on to the next chapter. Okay, so if you want some other problems, tell me. I'll surely make one more video for you for on the problems only. Okay, but if I don't want any such requests, I'll directly start next chapter from the next week. Okay, so decision is on your hands. Okay, but if you also try to solve much problems in textbooks, or you can ask the questions to me. I'll also give you the questions. Okay, so try to solve the problems by your own also. Okay, so with this we'll conclude this chapter, alternating current. Okay, as you know, we have completed so many topics in this, from the introduction, advantage, disadvantage, important characteristics, mean value, RMS value, and the source, AC source connected to resistor, inductor, capacitor. And next we started with the LCR circuit. We had derived the impedance calculation, LC oscillations, Q factor, power in the AC circuit, and transformers, energy losses, uses. Okay, so all the things we have discussed. Okay, so if you have any problems in any part of this chapter, you can directly ask me. You can text me, you can talk with me on the WhatsApp, or you can call me directly. Okay, but don't be with the doubts. Okay, so with this I'll conclude this chapter, alternating current. Okay, thank you.